Hello and welcome. My name is Tim Solley from VergeOps, and in this video, I'm going to talk about container orchestration with Kubernetes. We're going to talk about what is it, what problems does it solve, and how does Kubernetes enter the picture to make our applications resilient, fault tolerant, and able to recover from failures. They can scale and things like that. So stick around. I think you're going to enjoy this one. So before we get into what Kubernetes does and how it works, it's really helpful if we talk about what problems does it solve. In order to figure out what those problems are, we need to talk about how would we do things without Kubernetes. If we wanted to use containers, Docker containers, servers that we set up ourselves, how would we handle things like outages and failures of our applications, of servers, etc. So let's go over to my whiteboard here and imagine for a moment that we have a simple 3-server setup, whether they're virtual machines with Amazon EC2 instances or whether they're bare metal machines in our own data center. It would look something like this, right? We've got some kind of server. Now we know that we're going to be using containers, and right off the bat, as soon as we're using containers, we're immediately better off than we would have been before containers came along. But we're not quite there just yet. So imagine for a moment, you've got an application that you are ready to launch into production, and it's an e-commerce application. Now, everybody knows e-commerce applications. They know, what some of the features are. There's a UI of some kind or a mobile app, something kind of like that. We're going to have a REST API backend, and in our backend, we're going to have REST APIs for things like the ability to search for products in our e-commerce website. We're going to have pages to allow people to view product details, to see their prices and pictures and descriptions and things kind of like that. We're going to have a shopping cart where we can add items, update them, remove them, etc. And of course, we're going to have an order processing application in there where we're going to be able to put orders in, process them. And of course, there's many other applications that we would probably have as part of an e-commerce website, things for fulfillment and payment processing and, managing gift cards and, you name it, communications, etc. But we're going to stick to just kind of those core applications, a web application and maybe search, product, and a cart application, something like this. Okay, so it's day one. You're ready to go to production and we start our 3 servers and we need to go ahead and put our first application instance out there. So we go ahead and first of all, we've got to go onto each one of these servers and we need to manage it. So for example, step 1 would be something like, provision the server. And step 2 would be something like, SSH into server 1. Step 3, we're going to have to go and say, install Docker or some container runtime. And then finally, step 4 is we're going to run some command like this, right? We're going to say Docker run -d, which says run it in detached mode. We're going to, mount a port number. Let's say you're a Java developer. You're probably used to port 8080. Maybe you've got an environment variable like the DB URL equals, the URL to production DB or something kind of like that. And then finally, we put something like, search API, let's say it's V1. This is if you're not familiar with Docker, I suggest you go out and you find yourself a brief introduction to Docker. I am going to have more videos on Docker as time goes on, but that way you can understand what the heck this statement is doing. But essentially what it's going to be doing is it's going to start a container, which is just a wrapper around our application. So it's a way to get our application instance up and running in our server. So that's going to give us, I'll just draw them as kind of a circle here. That's going to give us an application right here. And this application is going to be, what do I call this? The search application. So I'm going to put a little S there to say it's a search application. And this one's going to listen on port 8080. Kind of like this, right? So there we go. We've got our very first instance of the application running on our little homemade cluster here. Now, of course, this is production, which means we've got to go and start up, at least a couple more copies of this same application. So we might go and repeat the procedure on servers 2 and servers 3. So we're going to put one here and one here. And this is going to be the exact same thing that we did down here. We had to do it on all 3 servers. We have to get the server, log into the server, set it up, get it ready, and then finally run our Docker container on there. And there you have it. Now we have our first application, our first REST API up and running and ready. It's our search service. But of course, we've got to go and do this for the other applications as well. So let's say that our product API, I'll do this one in black. Let's say we only want 2 instances of this one. So we've got to go on one of these servers and say, well, let's put one there. And let's just say, put one there. And I'm going to put a P for the product application. And so maybe now I'm going to go and I'm going to start up, let's say, my cart application. Maybe I only want 2 copies of that one. So here's my cart application here. And then finally, I'll put an order application out there. We'll do this one in this color right here. And let's say we want to make sure that people can always put an order through. So we're going to put 3 instances of it like that. And I'll put a little O to signify that one. So there you have it. And we now have all of our REST API components up and running in our little homemade cluster. Now we're not done yet though. We have a problem. We have all these instances of our application running on our servers. We need a way for our users to get their traffic to those. And so a typical way, and there's lots of different ways to do this, but what we might do is we might start up something like, let's say, a load balancer, right? Let's say we're in Amazon. We might use something like an application load balancer. And with application load balancers, it allows us to set rules inside of our load balancer to say, you know, when the URL path looks like this, like it has a certain URL path in there, route the traffic here or there. There's lots of different ways to configure them. But, you know, I'm running, let's see, 4 different applications here inside of my, my homemade cluster of servers. And so I need a way to route traffic to each one of those instances. And with application load balancers, at least, we do this with what we call target groups. Okay, so I might have a black one to signify my product. I might have a red one to signify my cart. I'd have a blue one to signify my search service, and this green or yellow one to signify my order application. So traffic comes in from my users. I've got a user out here, and their traffic comes in from their browser, and then traffic gets routed, you know, depending on the path, it goes to that one. I won't bother with the colors, but you get the idea here. So this one's going to route to my different instances, the product application. This one's going to go to my cart when traffic comes in. And it's just kind of load balancing across things, right? So here, here, and here. Hopefully you get the idea about how it is routing traffic. It's not important that you get the details at this point. The important thing to take away from this is that I've done all of this stuff manually. I've done it by hand. I had to go and set these servers up. I had to deploy my applications to my servers. Then I had to go to my AWS account. I had to set up the load balancer. I had to set up the target groups. Each one of these target groups has to have a registration of which instances of the application to send traffic to. And I finally have my application up and running and at least redundant at this point. But there's a big missing piece here. What happens when something goes wrong? That's one of the big benefits to Kubernetes, is that when something goes wrong, it can fix the problem for us. In this scenario, what happens, for example, when one of my servers fail? Let's say this one fails right here, this second server right here. Now it's 3 in the morning, you get some kind of an alert. Let's say you've got some monitoring set up and you get a text message or something that wakes you up and says, hey, you've lost a server, you've lost instances of your application. So you wake yourself up, you get to your laptop, you take a look at what's going on. And first of all, how are you going to know what instances of what applications were running on that server? You don't, right? Unless you somehow kept track of it. So this leads us to kind of one of the first areas of discipline that we have to have in this scenario, and that is that we needed to track what went where. That way we can recover from the problem. And the way you might do this is you would say start up an Excel spreadsheet. Let's just keep it real simple. You have an Excel spreadsheet. That spreadsheet, you have a column for all the different properties of each application instance, and then you have rows for each application instance, each one of these containers essentially. You put in there what the image is, what the environment variables are. You put in there, you know, port numbers, etc. You put all that stuff, you put the server that it's on, etc. That way, when there's a failure, you can go back and you can look at your spreadsheet and say, okay, I lost server 2. What applications were on there? And then you know, okay, there was a search, there was an order, and there was a cart instance on there. So what do? You go and you, let's say, get a server 4, right? So I'm going to go and I'm going to start up a 4th server. And now I've got to go on there. Once again, I've got to, so I'm provisioning it. I've got to SSH onto that server. Now I've got to install my runtime. And then I got to go refer to my Excel spreadsheet and run the 3 instances of the application that were on there on this new server. Okay, so now we're going to have let's see, we had a blue one. I won't bother with the labels. We had a green or yellow one, and we had the red one there, right? So there we go. Now we've recovered these three onto this server. But now I've got to go and rework all of my target groups up here to say, well, stop sending traffic to server 2 and its instances and start sending them to server 3. This is all manual. Now, if you're quick and you've done this before, maybe this takes you 10 minutes. Maybe it takes you 15 minutes, 30 minutes, something like that, to bring your application back to fully running. But maybe this is your first time, and maybe this is happening pretty frequently. Maybe it takes you an hour to recover from this, something like that. This is not an ideal setup, right? And of course, what happens when you forgot to update your spreadsheet? Like, I just made changes here. If I had my spreadsheet, I would have to remember to go in there and update that I put these 3 instances on server 4 and server 2 is now gone. If I fail to do that, the next time something goes wrong, my spreadsheet does not match reality. And this gets worse the more instances there are, the more servers there are, and that doesn't even count things like what happens when I bring on new team members to help me out, right? This is not great. Let's actually talk about that for a moment. What happens when I decide there's too much for me to handle by myself? So I'm going to go ahead and I'm going to hire somebody else. Excuse me. I'm going to hire somebody new. They're going to join my team and they're going to help me do this stuff. Well, my spreadsheet isn't going to work anymore. So I might do something like use a Google spreadsheet, which is shareable, or I might decide, you know what, I know that I'm going to be getting a third person in at some point, and so I'm going to put this stuff online, right? Maybe you're following the SRE model, which is engineers that work in essentially an ops role, and you say, okay, let's go ahead and let's put this stuff online. So I'm going to put a MySQL database, and I'm going to write a simple application that is an Angular application, and it's got a front end, and it essentially allows us with form fields and drop downs and things like that, allows us to manage what's going on with our servers. Okay, so we've taken one step beyond the Excel spreadsheets at this point, and we have made things a little bit more reusable. But I still have the problem of maintenance and of discipline. I have to make sure that the people using it do use it religiously, otherwise it gets out of sync. Okay, so maybe we hire a third person and that person is pretty sharp and they say, hey guys, you know, we've got this web application that allows us to put this stuff in a shareable format. What if, because, you know, we're on AWS and we're using, there's an API that comes with AWS. What if when you were to go and you were to update one of the fields, it automatically made API calls to AWS to go and get a new server and things kind of like that. That way we don't have to actually do any of the work. We just update our web application and it does the work behind the scenes. Now this is great. Now we've got some automation in place and we're getting much, much better here. And if you stretch this even further, you suddenly realize, oh, well, we could actually make it so that it could monitor our system. How about instead of, in response to a failure, going on there and saying, well, I want to add a new server. Instead, we could just have it check the servers, and when something goes wrong, it could automatically provision a new server and then look in this database to see what instances of the application were on that server and automatically move them over to the new server and deploy them programmatically. This is great. Essentially, what we've just done here is we've built an orchestration engine. And that's exactly what Kubernetes is designed to solve. So why go through all this, right? We want to let Kubernetes do all this for us. Okay, so let's talk about how Kubernetes solves this problem. Hey, real quick, I wanted to say that if you like this content, if you're finding this useful, definitely hit that subscription button and that little bell that notifies you when new videos drop. That way you can keep an eye out on all our new content that is coming your way. Okay, back to the video. Okay, so let's take a look at how Kubernetes does things. Now, this is going to look familiar to you at this point. We've got 3 servers, but notice the labels this time say worker. This is a key term that we use in Kubernetes. We call a server that has Kubernetes installed and is part of our cluster working together as a unit. We call them nodes. Okay, so this is a worker node. I'll talk about the other type of node in a few minutes. Now, a key difference between what we did before and what we're doing with Kubernetes is with Kubernetes, we're going to work with it declaratively. What I mean by that is in the last example, I had to do step by step by step myself. I had to say step 1, provision the server. Step 2, SSH into it. Step 3, install Docker. Step 4, install this application, this application, this application, etc. We don't do this with Kubernetes. Kubernetes already knows how to do these things. It knows how to run applications, as long as we give it the definition of that application ahead of time. So we're going to work with it declaratively. We're going to say, hey, Kubernetes cluster, I want you to have my application configured in such a way. I want you to have, for example, 3 copies of my product application, and we give it the details for that application. That's all we give it, and Kubernetes knows what to do with that. So that's exactly what we're going to do. I'm going to say, hey, Kubernetes, let's do the search application first. I don't remember what colors I was using before, but it doesn't matter. I say, Kubernetes cluster, give me 3 copies of my search application. And it's automatically going to, first of all, spread the copies of my application out for me across servers. This is, of course, so that if we lose a server, we lose the fewest number of copies of that application. So now I've got my search service running just like that. One step. That was all I had to do was say, here you go, Kubernetes, make this happen. Okay, and then of course I wanted a couple of copies of my my product application, right? So I say, hey, Kubernetes, give me 2 copies of that one. So it automatically spins off 2 copies of that one, like that. And I said, give me, let's say 3 whoops, get rid of that. I said, give me 3 copies of my, what did I say? This was the cart application. So there's my C for the cart application. And of course, 3 copies of our order application right there. Okay, so there's our order application. So this looks very much like what we had before. But this time, I just told Kubernetes, hey, go spin up my application for me. It was a much, much simpler way of working with things. Now, in the last application, first of all, I had to keep track of all this stuff. I had to keep some kind of a database of what servers I had, what instances of my applications I had, etc. This time, Kubernetes does that for me automatically. It has its own database, and in that database is all of my details. Everything it knows about everything with my cluster is all kept in a database that is called etcd. More on that in future sessions. Okay. Now, in the last example, we had to go and set up a load balancer. Well, the great thing about Kubernetes is because it already knows all of the details about my applications, it knows how many there are, it knows their IP addresses, what servers they're on, it knows what port numbers they listen on because I told it when I gave it my application, it has everything necessary in order to set up things like load balancers for us. In addition, when Kubernetes is running in a cloud environment like on AWS, Google, Azure, it knows how to work with the cloud API, right? Those are all API-driven systems. I can, go to a web application, I can go to an admin console, or I can use a CLI or something like that and say, go give me a load balancer. Well, Kubernetes can do the same thing. It can call that API and say, go get me a load balancer and do things like set up target groups, etc. So I'm going to skip the part where I had the target groups, and I'm just going to, let's say, set up a simple load balancer, and this load balancer's job is to send traffic there, there, and there. So it comes in from my users. Here's my users in their browser or in their mobile app or whatever, and it knows, hey, let's set up, server 1, server 2, and server 3, like that, right? It's going to automatically configure and provision that load balancer so that when traffic comes in, it automatically gets routed to the servers. Once they get to the servers from there, Kubernetes has its own way of routing traffic to the various instances of the application. We call these pods in Kubernetes. Okay, so the load balancer is pretty dumb. It doesn't do much. Traffic comes in and it just routes it to one of my servers. Now let's take this back to the example we used in the last example, where we were doing things manually, right? What happens when something fails? So once again, I'm going to kill worker node 2. Now in the last example, we got some kind of an alert that said, hey, something is down. We need to go and fix it. Kubernetes doesn't work that way. If properly configured, Kubernetes will respond to this problem immediately, and it will do it automatically. And when I say automatically, I'm talking we can resolve this situation in just a couple of minutes. The first thing it's going to do is it is going to try and heal my applications themselves. Okay, it is keeping an eye on all of my applications. Remember, I did things declaratively. I told Kubernetes, I want 3 applications of my search service and 2 applications of this and 3 instances of that, etc. It knows that information and can try to monitor the system and maintain that at all times. It says there should be 3 copies of the search service. So I'm going to keep checking on the search service and make sure it's always up and available with 3 copies. And in this example, I've just killed one of those copies because I took the whole server down. So it's going to look at each one of these independently and say, uh-oh, I've lost an instance of each one of these. I need to recover them. So it is first going to try and recover one of these. And the first thing, I'll just use the search service. It's going to immediately spin up a replacement copy on another server if there is room somewhere. And in my example, let's say each server can hold 4 pods, 4 instances of applications. So I've just filled it up, right? I went from 3 servers down to 2. I had one sort of open slot here, and it recovered my search service and put it right there. So now my search service is back to 100% capacity. It is perfect now. But my product application, my cart, and my order application are a little bit lagging. So of course, we need another server to replace worker node 2. Now in the last example, I had to do that by hand. I had to go and click on a console and say, go launch a new server for me. But Kubernetes, just like how it was able to get the load balancer, it can do this automatically. It can call the API and say, give me a new server. So I'll draw a new server right there. There we have, there's a worker node 4. Now, as soon as this server comes online and is healthy, which usually only takes a couple of minutes, Kubernetes will see it and it will start routing traffic to it as well. And it will say, okay, the product, the cart, and the order application have been waiting on some place to run. So let's go ahead and run those. And so now I'm going to get a new cart. I'm going to get a product, and I'm going to get an order application. And there we go. Now all my applications are back to 100% capacity. I got a brand new server, and I was able to sleep through this whole thing. That's the beauty of Kubernetes. Now, this was the healing scenario. Scaling works very much the same way. When it comes to auto scaling, Kubernetes is going to watch our applications and try to maintain some kind of a target. I can tell Kubernetes things like maintain a certain CPU or a certain memory load or something kind of like that, and then scale either up or down, or should I say in or out. Those are the terms we use when we talk about adding or removing instances of the application. If the CPU or the memory load goes too high, just go ahead and add another instance of the application, right? Or if it goes down, remove one, right? So it can just kind of all day long sort of scale in and out the different applications. Now, if they don't have a place to run because I've created too many of them, and when I say I mean my Kubernetes cluster, if it's created too many of these pods, it will automatically recognize that it needs more servers and go to the cloud provider and get more copies or more servers and add them to the cluster. So all the applications are growing. Then we need more servers. The cluster itself grows. And then let's say in the evening your application gets real slow. All the pods start shrinking back down. The servers then start shrinking back down as well. Okay, so this is how it automatically scales and things like that. Now, so far, you'll notice this looks just like the other example over there. They look pretty much the same. What's missing here is what we call the control plane that Kubernetes has. Something has to run somewhere to say, do these changes. Go get a new server. Go get a load balancer. Do some configuration changes. Spin up new pods. Remove some pods. Do some scaling. Things like that. We call this the control plane, and the control plane is centered around some servers, and we call these master nodes. And notice I drew them kind of in a red color. So these master nodes here are going to hold themselves a variety of pods. And remember, a pod is the Kubernetes word essentially for an application instance. More about that in the future. Now, each one of these pods has a different job. Some of them are responsible for things like networking. Others are responsible for things like providing the Kubernetes API itself. Others are responsible for things like maintaining specific numbers of copies of pods. Others for auto-scaling. You get the idea. Each one of these is doing different stuff. And all they're doing is saying, hey, let's, manipulate all this stuff, right? And maybe go out there and talk to the cloud provider and make changes, get servers, get load balancers, etc., things like that. This control plane is making all this magic happen in an automated way. Now, you can have one server, you can have two, you can have three, etc. You obviously have redundancy that we need for this. It's a very important part of Kubernetes, and therefore we want some redundancy. And so I have 3 copies here, but I might have more. I might have 5 copies, 6 copies, something like that. It just depends on how big my cluster is, how many of my worker nodes I have, how many I need here. Now, we are going to interact with this here. When I say we, I mean administrators. As an administrator or somebody using Kubernetes, I am going to interact with that Kubernetes cluster through these. I'm never going to touch these servers up here by hand. I'm going to interact with the Kubernetes API, which runs here. And that is then in turn going to make changes up here. So for example, if I decide, you know what, 3 copies of my search service is not enough, I want to go up to 6, I interact with this one up here and I say, hey, Kubernetes, give me 6 copies of. I want to go from 3 to 6. And Kubernetes says, okay, cool. I'll take a look at the current state of things. I see I have 3 copies. I'm supposed to have 6. Therefore, I'm going to launch 3 brand new copies of my search application and distribute them around the cluster and make any changes to networking configurations, etc., so that traffic just automatically starts to flow to those instances of the application. And so there you have it. There is a very, very brief look at Kubernetes from a very, very high level. Now, as you dig deeper into Kubernetes, it helps to have an understanding, okay? Kubernetes has a very steep learning curve that comes along with it, but don't let that scare you. There's a lot of concepts, there's a lot of abstract ideas that are involved in it, and those things can make it a little bit tricky to learn. But it all starts with a basic understanding of Kubernetes and sort of what its purpose is. And so this is why I try to give you a quick tour here of, what does it look like without Kubernetes, and what are some of the problems that come along with that? And then what does Kubernetes do to solve those problems? Okay, so I hope this was a good primer for you, and I hope it will allow you to go into your Kubernetes journey with some understanding of what the goal is and what you're going for. So thank you for watching this video. Definitely subscribe to our channel and turn on that notification bell. That way you can get updates as more of these come along, because we're going to be dropping a lot more videos very much like this on things like Kubernetes, things like Docker, AWS, DevOps, etc. There's going to be a lot of things coming your way. So thank you for watching, and I'll see you in the next video.